Assalamu alaikum. How are you guys? Hope you are doing well in this pandemic situation. Actually, in this video, I'm going to tell you about six different sensors, their schematics, and their code. These sensors are the heartbeat sensor, current and voltage sensor, temperature sensor, and SD card, which is used for data logging to store all the values measured by these four sensors. First, I'll tell you about the heartbeat sensor. Actually, this heartbeat sensor is used, as the name suggests, it is used to measure the heartbeat of a person. Since it is schematic and there is no human involvement in it, so I'm using a variable register here for the interface. This button here is used to give the signal to start measuring the values. For this, first I'll have to add the library of the heartbeat sensor in Proteus. Then I have to add this hex file here in the heartbeat sensor. This hex file will be provided in the zip file that I'm going to send. Okay, so this is the LED. LED 4 pins are connected here. This one is used for brightness control. This one is ground. This one is the source. This oscilloscope is used to just show the wave signs of the measured here. So let me show you the code of the heartbeat sensor. um, Here is for the LCD I'm using this directory, and for real time storage I'm using these three time one wire and RTCV libraries. It is used for real time values. Okay, like the time that is right now, it will show this time on the serial monitor. So I'm using a the pins. These liquid crystal LCD pins are 13, 12, 11, 10, 9, 8, and the pins that are used for HB heartbeat sensors are 4 and 2. The other variables you are seeing here is are just here to store different values. Serial dot begin is for serial monitor, which is used to print different values. So here is the LCD dot begin means here I am telling the code that it is a 16 cross 4 LED. Okay, so HB sensor is 4 pin number, so it is the input, and HB start is also the input. So here I am initializing the timer, and the attach interrupt. LCD clear is used for the clearing. LCD dot set cursor is used to set the cursor at this coordinate. The coordinates mentioned here are for the to place the cursor in these coordinates. LCD dot print is used to print these values here. So let me just show you the code where different HPs measured. So if the HB dot start is low, if I press this button, and when I press this button, it will give the signal to heartbeat sensor to start measuring the HB value. So HB dot sensor, if HB dot sensor is low, it will start counting the HB values, and it will go check. It will give HB start check one value. So it will, after getting out of this if function, it will enter in this if function and start counting the HB values and printing them. When it reaches 10 second, when the time is reached 10 second, it HB count, which is for 10 seconds, is multiplied by 6 to make it a count of 1 minute. After which is after that, it is stored in HB per minute variable, which is then printed on the LCD monitor. Let me show you the simulation here, and you can see it for yourself. Okay, it is taking time. Okay, yes, here is the When I press this button, it is giving this signal and the HB level is counting now. It will go up to 10 seconds and then it will stop, and HB per minute will be given to us. Let me just wait for 10 seconds and it will give you. Here is the oscilloscope which is giving the waveform which is given by the heartbeat sensor, and after 10 seconds it will stop measuring and give me a HB per minute, which will be almost, I think, at this rate it will be 42 or 36, I think. It will be nearly, yes, there it is. The HB per minute is given by 42. Now here is it is telling me to press the button again to again measure the HB value. Again I will press this button and it will start measuring the HB count again. um, yeah, it is counting HB again, and HB count is then again measuring 1 2. It will go up to 10 seconds and then give me HB count again. So this is the basic code and working of this heartbeat monitor. And let me just show you the voltage sensor as well. As you know, the voltage sensor is used to measure the voltage. This is the voltage sensor. The voltage measured here will be shown through this, and this IO0 shows that it is connected to this pin. All right. So the when I just start this start to simulate, it will and it will give me voltage that is measured from this pin. um, Here the voltage V is 1 volt. Here 1 volt is being given out by this value. Okay. In the similar way, the current sensor is providing, as you know, for current sensor you have to put it in series. So I have broken it into pieces, like the first end is connected to this end and the second end is connected to the IO4 of the Arduino. So it is in series with this circuit. Okay. So the current measured by this is given here, that is minus 13.15 volt. If I just change these, it will give me it will give a positive current value. Okay. So here is the value. Let me show the code of voltage and current sensor as well. Yes. The for voltage sensor, the analog pin is A0. For current, it is 3. These values are to calculate and store in these variables. Okay, so here the get voltage is for the input, and the get current is also for the input. For the temperature, yes, the raw value is getting the analog output from this. Then the raw is given to the map function, which then gives us the intern value, which is measured from the voltage meter and stores is in VAL variable. So the measured voltage is given into the VAL variable. Same procedure is same thing is happening here in current sensor. The get current same function gets the value of current which is measured from the current sensor, and it is stored in measure variable. Okay, so the current I am getting is stored in measure variable, and it is printed on serial monitor, as you can see here. So these are the basic function. Let me just show you the get current same and map function as well here. Yes, here is the get current same. In this, it is just taking the values that are given from the current sensor and just averaging the values here, and making it between the appropriate values. The same is happening in this map function, which is just taking different values provided by the voltmeter, and just in the appropriate formula is used to make it the value which is needed. Okay, so Let me just take it now to the temperature sensor. These two sensors are also done here. The temperature sensor here, I'm using LM35 temperature sensor. So one pin is used for input, three is for ground, and the second is the analog pin, which is used to measure data and send it to the microprocessor. So let me show you the code of this here, and here is the measure sensor is here. Here is the constant integer sensor, which is a 0, and now the temperature is yes. The Vout gets the values of the reads the value from the sensor and then stores it in Vout. This formula is used to convert it into appropriate values, and this temp which is to convert it into Celsius or centigrade, and here it is converted from centigrade to Fahrenheit and stored it in these variables. Temp C is for centigrade temperature and temp F is used for Fahrenheit temperature. In so here these temperatures are also printed. Okay, so let me just show you these values. Okay, in the serial monitor, so you can see it for yourself that these values are here, and okay, yes. So you can see that voltage is 1 volt, DC current is minus 13, temperature is 27.3, and in Celsius, and temperature in Fahrenheit is 81.7. You can also change the temperature from here, like if I increase here, it will increase here like this. You can see 33.4, 34.21 is in centigrade, and 93.58 is in Fahrenheit. Now the final one is the data acquisition, or you can also say it SD card data logging. First, before I tell you about this data logging and data acquisition, let me just first tell you that before you start using it, you should have one file, that is image file of the SD card. Okay, I'll show you how to make an image file of the SD card right here, so you can use it. Okay, so here this is a software called WinImage. You download it to make the image file used in the SD card. Okay, so you just need to click on File and in New, put the standard format on 1.44 and import it. Click on Custom Image Format and then OK. Because I'm just making a 4 MB SD card, that's why I'm using 4, and keep the file system on FAT12/6. Okay. After clicking OK, I'm going to save it. You can save it as image file. As you can see here, I'm saving it as image file IMA, and I'm saving it on desktop and giving it a name SD card, and I'm saving it. So you can see here is the SD card, and after this I'm going to store a text DAQ file in it. I've already made a dot text file, so I'm going to just drag and drop in it and click yes. As you can see, here is the DAQ file, and there is nothing inside it. Okay, so let me just save this and close it. Now after you just have to right click on it and go to edit properties, and here in card image file you just have to browse and desktop. You just have to search the name that you've given your image file. I've given SD card, so SD card, here it is. I'll just open it and okay, that's done. So let me just show you the code here of the SD card. For SD card, well, you see these two directories are involved in the SD card. The variable name is used my file, which is used to write, open, close, or print in the file, that DAQ file that I have created in the SD card image. Okay, so here let me just show you the code where I'm just saving the yes. Here, my file, in my file, I am just using sd dot open, and then I'm giving the data and the name of the file that I've given in the image, SD image file. Okay, here is the image file. Okay, and I'm giving it that I have to write in it. Okay, so I'm giving if the file is if my file, that means if the file is opened, okay, then I will write in it. Serial print data writing to daq.txt. It is used to print on serial monitor to let me know that it is writing properly in the daq.text. All right. So that date time now is a variable which is used to get the real time. By real time I mean the time that is right now, like 6:24, 18th of June, etc, etc. And my file dot print is used to print on that file that I have opened. Like I have opened here DAQ file, so it will print on this DAQ file these values: HB per minute, per voltage, current, temperature in centigrade, temperature in Fahrenheit. Then it will print the time and date that these readings are measured. Okay, the as you can, or as I have already told you, the serial dot print is used for serial printing, to print on serial monitor. My file dot close is used to close the file document. Okay, you have to close the file document when you open it. It is or it will not run properly. And serial dot print is used. This is telling me that it is done. And if the file doesn't open, it will tell me that there is an error opening DAQ file. Okay, that it is missing or something other error is happening here. Okay, here the time dot lsr, it is giving times in 10 seconds, etc. These functions I have already explained it to you. This is the SD card int is used to check if the SD card is working properly or not. If it is working properly, then it will give a message that initialization is done on the serial monitor. Otherwise it will show that initialization has failed and there is some error. That is why the data I'm trying to store is not stored in that file. Okay, so here is the DAQ file. This is testing. It is used for testing that it is storing data or not. And here is a serial print. If it doesn't open, it will show error opening DAQ. If it does open, then it will just store this testing 1 2 3 4 test. The same is happening here. It will store the data DAQ text file, and if it doesn't open, it will give you an error. And it is for real time. If the RTC is not running, it will tell me that it is not running, and if it is running, it will just tell me that it is running. And this is the RTC cop. It is used for giving me the current time and date, which is right now. Let me just run this schematics and I'll show you how it is stored. Okay, let me just check one more time if this is saving or not. It is saved correctly or not. Okay, open and okay. Let me just simulate it one more time. Okay. As you can see, the initialization is done and it is starting to store the data. Let me just store it one time here and I'll show you the value. Here HB is counting. HB level is counting. After 10 seconds, it will stop counting and I'll show you the data which is stored on the DAQ text file which I have created. So you have to get that software that I have mentioned, WinImage, to make the image file. Otherwise, it will not run properly on the SD card would not run properly, and it will not simulate properly. As you can see, the 10 seconds are over. It will just show me the message here on CM monitor that it has done writing. Yeah, the message here is shown. So let me just show you the value stored on the DAQ. Let me just stop it, and the SD card is here. Let me open it. DAQ.text. Open. Okay. As you can see, here is the data, and the time is same, 18:28, and here is 6:28:29, and the date is 6:18 and 6:18. So that is all for the simulation. So if you have any query, you could just ask me or tell me in the comments. And the final thing that I wanted to tell you about was one of the sensors that I wasn't able to find on the Proteus, and I couldn't find that sensor's library as well. That's the sensor is the oxygen sensor MAX30100. Well, let me show you the data sheet here. It is here, yes. Well, its operating voltages and different ranges are here mentioned. Its operating voltage is basically between 1.8 to 5.5 volt. It has two LEDs, which is one is IR LED and the other is red LED. The IR LED is used to measure the pulse, and to measure the oxygenated blood. Both IR and red LED is used. To understand its working properly, you just have to know two things about it. There are two types of blood: the oxygenated blood and the not oxygenated blood. The oxygenated blood has large volume, and the blood which is not mixed with oxygen has low volume. So when the heart pumps, there is an increase in oxygenated blood, and when the heart relaxes, there is a decrease in oxygenated blood. All right, so the time difference between these increase and decrease in blood and give us the pulse rate of a human body. So here is the pin layout of the MX30100. This is the input voltage. The SCL and SDA are serial clock and serial data pins. Int is for interrupt pin, and IRD and RD are not used here, and GND is used for ground. So it works in a way like that. I put my finger here on this LED. The IR waves emitted by these LEDs is absorbed by my finger. Okay, so the amount of IR waves absorbed by my finger will tell the amount of HB level and the pulse rate which is in my body. Okay, so basically the more the IR waves are absorbed, the HB level will be high. The lower the is absorbed, so HB level will be low. Okay, so that is all. If you have any queries, you could ask me in the comment section. So that's all. Hope you guys are doing well. I pray to God that everyone is fine at their home, and hope you will take care of yourself in this pandemic situation. Please do like this video and take care of yourself, guys. Just take care of yourself, and if you have any query, just tell me in the comment section. Okay, Allah Hafiz.